In this video, we're going to talk about how stack, specifically call stack, and how it is relevant to passing arguments into a function. Before that, we need to understand what stack is. In computer science, a stack is an abstract data type that serves as a collection of elements. So you can think of this stack looking like this. Stack is last in, first out. So if you look at the stack and the very first element of the stack, I index 0 sits on the bottom, 1, 2, all the way through n. The very first element that gets into the stack goes in on the bottom. The second element goes in on top of the very first one, and the third element, and the second element, and first element, like so. Every time you insert an element into it, we call this operation push. And every time we need to remove an element or release an element from this stack, we call pop operation. So push and pops. Both operations are responsible for adding information or removing information out of stack in a LIFO fashion, meaning push adds an element to the collection and pop removes the most recently added elements that was not yet removed. Last in, first out. This is in reverse of Q, which is first in, first out. How is this relevant to call stack? To understand what a call stack is, you can think of a call stack as a collection of frames, or sometimes we call them activation records or activation frames. These are machine-dependent data structures containing subroutine state information called stack. Specifically, each stack frame corresponds to a call to a subroutine or function which has not yet terminated with a return. So in other words, what you're seeing inside of each of these space that we call frame or activation record stores some memory addresses or value inside of it. A memory address itself is an integer. So you can think of the entire call stack like this at runtime, sitting inside of your computer memory, responsible for aggregating integers. And if you look at this memory address and content, you can think of it as a call stack that we have on the right side, where each frame contains the memory address and the content sitting inside of it. So this content holds the memory address of whatever was inserted at runtime. And because stack is last in, first out, we need to have some sort of pointer that constantly points to the top of stack. So this is also called top stack pointer. And this top stack pointer keeps track of the top positions at any given moment, meaning when you start to insert or push information into your stack goes up, your top pointers will be moved accordingly. Whenever computer decides to release information, that's what we call pop. This information then lowers the top pointer because as you pop information, your stack pointer moves down in this fashion. So this is push, this is pop directions. Let's move to the next page to illustrate how this is relevant to passing arguments into a function.